momentarily. Okay. This is, okay. So regular expressions. So I was wondering, I wondered for quite a while of which language to use for this, and I think that regular expressions is something that exists independent of languages. And so what we'll be using today is this website, just so that we can get accustomed to the different to the various features of regular expressions. And maybe at some future date, we can look at more advanced applications of regular expressions using an actual language like Python or Perl, or even using maybe if we have the time today, we'll get around to it. Maybe we'll use some of the shell tools that we have commonly available to us, like grep or sed, which typically where you can use regular expressions to be able to do some kind of text searching or text manipulation. So for those of you, if you go on the issue, you can find the lesson material at the link at the bottom, and you can follow along here. That's what I'm going to be using for here. Sorry, I wasn't able to print my notes, so I just want to pull them up on my phone so I can follow along. Sorry for the delay. All right, sorry about that. Okay, so one thing I want to cover is a bit of the motivation of why you would want to learn regular expressions. And so for me, for the longest time, I had kept hearing about this thing called regular expressions. I've seen T-shirts saying, "Hey, I know regular expressions. Look how cool I am." And I was always wondering, like, what's the point of regular expressions? I only recently was able to learn and I can learn how to actually use them. And ever since I've learned them, there was no going back. Their utility crops up everywhere in my work, and not only my research work. Like when outside of research, whenever I have to deal with plain text and I have to search for some text in a bigger block of text, and there's a pattern, and now knowing regular expression, I can search for that pattern and readily do this, as opposed to doing dragging and selecting a text very manually. And so I think regular expressions are extremely useful. They can be used for searching, but they can also be used for text manipulation. If we get around to it today, we can go over a bit of that. And what I'm going to be showing you today is just the basics. So the basic components of regular expressions. And hopefully this will give you a nice foundation to then learn any extra ones on your own going forward. I still Google to this day different patterns in regular expressions that I'm not very familiar with, or some that I've forgotten. And I know they exist, but I haven't really used them myself. So I hope after today, you'll have an understanding of the basics of regular expressions, and you can then learn on your own in your own time. So if y'all have regexpal open, what I'd like you to do is just copy paste this block of text here into regexpal in the bottom, so that we're all on the same page. And so what we're going to be doing is we're going to just this is just a random DNA sequence, and we're just going to go through the basics of regular expressions to understand how we can use them. So I guess first thing, I'm assuming you all have the lesson notes open somewhere in your. Oh yeah, so sticky notes. For those that aren't, I don't have it. It says sticky notes. So on your desk, you have the blue sticky note, a red sticky note. Blue sticky note, put it up on your laptop if everything is going good, and the red sticky note if it's a flag basically say I need help, and one of me or one of the helpers or someone next to you who has a blue sticky note up will maybe give you a hand. So does everyone have this page up under laptops? Put blue sticky notes up to make sure that you do. So this is just some DNA sequence, and one thing that we can do is just simply search for a certain pattern. So just a bit of an introduction, I guess, to a technique in biology is there's these enzymes that we commonly use that recognize a specific sequence, DNA sequence, and then cuts it. So what we're going to do is we're going to search if this DNA sequence here has those what we call recognition sites. So if you look on the notes, you have a table here of a different recognition sites for real and not so real restriction enzymes. So what we'll do is if you want to search for, we'll just look for the first one, echo R1. We'll just search for if this DNA sequence has instances of these of this restriction site. And as you can see, if you just simply type that text in, you'll have two instances of that recognition site show up in the in this DNA sequence. So please, blue stickies up if you're able to do this, just to make sure we're all on the same page. Red stickies up if ever there is, if you can't get this to work.
Sorry, I missed that. You just pasted it and pressed enter, or how did you get it to highlight it?
Okay, so I think if you copy paste, I think you just have to you have to add a space and remove it. So you have to just make it recognize the sequence, the pattern. So does it work?
No. Oh, okay. Okay, you can't have any. Your cursor has to be at the end of the sequence. The cursor can't be a line below. So back.
Oh yeah. So okay. So it's funny that we run into this because yeah, that's a warning later on. So yes, if ever your pattern is not matching for some reason, make sure that you don't have a new line in your pattern. So if you see my cursor here, it's on the second line. And white space in regular expression matters. So if I simply add a space in the middle here, my matches are lost because there's no such sequence. So make sure that you keep your, your cursor can't go beyond the end of the line. All right. Now let's say we have another restriction enzyme here, the second one, BAMH1, and if we were to just put this one in, you'll notice that there's only one site. So again, if you're able to get this one recognition site, everything should be good. Now this is trivial. This isn't. You can just do this with any search tool in any text editor ever in the history of text editors. So there's nothing really sophisticated here. But let's say you want to know anything that can match either one or the other of these possible recognition sites. So the idea here is, okay, what if I use both of these two enzymes? Where would it cut in total? And so to be able to accomplish this, there's the OR operator in regular expression. So first you take your first recognition site, and you use the pipe or the vertical bar, and then you follow it by your second pattern. So what you'll get is something like this. So you have your first recognition site, the pipe, vertical bar, and the second recognition site. And the way you read this in regular expression is like, could you match this part or this part? You're giving regular expression to look one or the other of your sequences.
And again, there should not be space.
No spaces. So here, if you add spaces like this, like you were, it will not work. And this is because what it's doing instead is it's looking for GAATTC space or space GGATCC. And that's not what you want. You want strictly the sequence, because in your DNA sequence at the bottom, there are no spaces. So blue stickies, if everyone has gotten that far.
What's the difference between the yellow and the blue highlight?
It's just to alternate. They alternate. Just to show if ever you have adjacent patterns that match, it's just to delineate between the two. I guess if I did a crazy example here where I'm matching every single character, it just shows that each character is alternating. So now that we have one or the other, we'll do something a bit different. So some restriction enzymes, such as echo R2 here, has this W. And W is an ambiguous nucleotide. It means either A or T. And so this is where you quickly run into, if you were to search for this in your text editor, you would run into issues. Because how were you to represent? You would have to search for, there's one alternative, is you can search for the A version or the T version. And this technically works. But obviously, if you were to expand every possibility, you realize that you'll have a bunch of things one after another, or this, or this, or this, or this. And there's a more, elegant way of achieving this. And this W, and this is using the square brackets notation. So when you, in square brackets, you can specify a list of characters that you can choose that can match at that position. And you only choose one of those characters. So in this case, I want either A or T. So the way you read this is, okay, match CC followed by either an A or a T followed by GG. And here we have the same two sites that get matched, where you have, and in one case it's the A, and the other case it's the T. So everyone has got that far? Now let's say we want to match all three of these recognition sites. What we could do is we can combine our square brackets with our pipe. So we have one. I'm switching back and forth between the two screens. No spaces. Here I have the first or the second, or CC, A or T, GG. And how what we have is we have all of the sequences that we've matched previously highlighted in this DNA sequence. Now, having seen this, we'll jump to our first challenge question. And so everyone put your stickies down. The challenge question is, write up a regular expression to identify the cutting sites or for this boom H1 recognition sequence. And note that the ends here at the bottom refer to A, T, G, or C, so any of the nucleotides. And I'll just put this here. And I also left a hint. If you do notice repetition in your pattern, you can start looking to jump ahead and look at quantifiers. There's a way of solving this without using quantifiers, but if ever you do notice repetition, we'll look into how we can simplify regular expressions. So yeah, so try and come up with a regular expression to match this here.
Do all the ends need to be all A's or all T's?
No,
or
it just
can be anything?
Exactly. It can just be any string of 4 nucleotides. So once you got it, you can put your blue sticky up, and if you are if you think you have any questions or problems, put your red sticky up.
Bruno,
Yeah.
Bill's listening in from.
Yes.
And he's just asking if when someone from us asks a question, if you can just repeat it for them.
Oh, yes, good. So does everyone has their red stickies or blue stickies up? Has everyone been able to solve it? Can anyone volunteer to give us their answer or their pattern that worked? No. Oh, sure. Sorry.
Well, the really fast version is just to type in CTGC and assume there's going to be 4 characters at the end because DNA pretty much never ends.
Yeah, that's I guess, easy.
But then you could run into problems if it selects the last few characters.
I guess, yeah.
And then the other way that I did was do a square bracket with all 4 possibilities, and then I repeated that 4 times. And I'm sure there's a better way.
Yeah, so this basically does what we want. It matches those first 4 nucleotides, CTGC, and then matches any one of the 4 times. And so here we have 2 examples of that here. Now, if you look at this here, we have some repetition. And in regular expression, there's a way of allowing this, there's a way of accounting for this kind of repetition. And so, and this is using, there's multiple ways of achieving, allowing for repetition. And so for this, what we're going to do is we're just going to look for other kinds of features in this DNA sequence. And we're going to just move to part 2. So let's just look for strings of T's. So if you want to look for all T's in our given in our sequence here, you can just type the letter T and it's going to highlight all of them for you. And here it only matches single T's. So that's why if you have multiple T's next to each other, they alternate in color because they're separate matches. Now, there's a way of specifying regular expression. Let's say I want 1 or more T's. And the way you do this is you can use the plus operator. And so what the plus does is it looks at the previous subpattern. In this case, it's the T. And it says, OK, I want this 1 or more times. And so here what you have is you have stretches of T's that are matched in our DNA sequence. But obviously here, let's say we want repeats of T's. So I wouldn't consider a single T to be a repeat. And so so you can be a bit more explicit. So unfortunately, there isn't a 1-character shortcut for 2 or more. And for this, you need to go into the more general curly brace notation. And I have this in the notes, but basically the notation using the curly braces is you can specify a single number if you want that specific number of counts. So if I give a 2 in curly braces, we have all instances of 2 T's next to one another highlighted. You can give a range where you say 2 to 3 strings of 2 or 3 T's. You can omit the last number and just say 2 or more. And this is what we would want here. So in this case, what this is saying is that, OK, I want any stretch of T that is minimum length 2, and we don't have a maximum length. And here what we have is all T's that exist here that are length 2 or more. Now, let's say I'm interested in the dinucleotide TA. You may be tempted to just add an A here. But there's an issue with this. And so one thing you have to understand about quantifiers, and this is maybe a bit tricky, is that the quantifier only affects what is immediately before it. And in this case, that is the A. The T and the A are completely, in regular expression, they're separate, and the quantifier only affects the one that's immediately before it. And so in this case, what we have is anything that starts with a T and has 2 or more A's. And in this case, you have that here. So what you want to do is you want to somehow group the T and the A together. And you can use this using parentheses. And so what we have here is the quantifier is being applied to anything in parentheses. And this is called a group. And so you have the TA here being repeated.
And then that's different than if you were using square brackets, right? Because you'd also get AT with the square bracket.
Pardon?
Like if you use the square brackets
Yeah.
instead of the round brackets, you would get A and you get the A and T as well as T and A.
Exactly.
The round brackets, you only get T I didn't know that.
Yeah. So so here, let's say you use square brackets. So what square brackets does is the order doesn't matter, and it matches only one of the characters specified in the square brackets. So in this case, it's any string of A or T's, regardless of order. While if you use the curly the parentheses, what we have is the order now matters, and it looks at the characters in the order that is specified in the parentheses, and that specifically needs to repeat, in this case, 2 or more times.
It's not just the order, like this combination. It's looking at this TA combination.
Yeah, that combination and order 2. So if I did, let's say, AT, we have different matches. Obviously, there's overlap. If there's a stretch of ATs, you'll have inevitably a stretch of TAs. But in parentheses, the order and the exact characters matter. While the square brackets is any one of the characters inside the square brackets can match.
And then the quantifier changes too, right? So like if you're in the round brackets, so I'm just thinking this.
Yeah, sure.
In the round, if you use the round brackets, your quantifier of 2 is no longer 2 characters. If you have.
Yes. So
Yeah.
exactly. So that's a good
You're
point.
better at explaining that.
Yeah, no, that's a good point. So the idea here is, when you use round brackets, it's that group, that component is repeated so many times as specified by the quantifier. So in this case, AT is 2 characters long, and AT has to happen twice or more. So in the case of square brackets, what you'll have is any one of the characters is matched. And so the quantifier is, so that's why the square brackets, you can imagine that always matching any one character. So even though you have a really long square brackets where you have a bunch of different characters in it, only one of them is going to be looked to match. If one matches, it will just use it and it'll match.
Like if you put 1 as your quantifier there,
Yep,
you
that's
get 2 characters. Just get rid of your comma.
yeah.
Yeah.
So if you were to use square brackets here, it's just matching one character. So that's something you need to keep in mind. So oh, sorry.
So if you use that 18 square brackets and then put 2 comma.
Yeah.
The TA at the beginning is highlighted, but shouldn't there be more than 2 of those?
So yeah, there's the confusion. So why here that first T is being highlighted if we're asking for 2 or more? So the square brackets basically means one of the characters within the square brackets needs to be matched. And so in this case, it's T is being matched and A is being matched, and those are 2 separate, and that's why it becomes highlighted with 2 comma. So if I just change this to 3, for instance, what this basically means is that square bracket notation is only one of the characters in the square brackets gets matched. So in this case, if you have 3, then it needs, how to put it? Basically, any one of the characters in the square brackets needs to be matched 3 times in a row. So that's why the length here. So that's a good point raised by Tiffany. Is the quantifier does not refer to the number of characters. It refers to the number of times the previous component happens, and that component can be either, in this case, 1 of 2 letters. It can be 2 letters if I were to use parentheses, and so on. So we're going to move on to challenge 2, which is going to be a bit trickier. And so challenge question number 2, we're looking at phone numbers, and people there's so many different ways of writing phone numbers. And so what I'd like you to do is come up with a regular expression that can match all, in this case, all 6 of these phone numbers and their different formats.
When you say match, you mean like make them highlight?
Yep, so the entire thing, yeah, make sure that they match. Oh, okay.
If you want matching, like the 10 numbers or 11 numbers in the case of the last one?
All of them.
I get all of them, yeah. Yeah, okay. I guess this is cheating. We'll get around to this later, but try and match it in a way where you're looking for a sequence of digits and Or okay, how about this? How about this? We're looking for the 10 numbers, so 3, 3, 4. Try and match that in all 3 cases. Try and match the 10 numbers, so the 3, 3, 4. Try and match those in all on all 6 of these lines.
Okay, I think,
Put your blue stickies down, and once you figure it out, put them back up.
so
Yes.
I think you have this instruction you have here for the question mark and asterisk, and probably you need that here. So you describe.
Oh, yeah, good point. I skipped over that part over my notes. Sorry about that. So, yes, so another, I jumped ahead into the more specific quantifiers. Thank you, Jose. So, another common, so I already showed you the plus operator, which shows you 1 or more. A variant on that is the asterisk. In this case, it doesn't really change much. It's 0 or more. So this means, okay, there could be this character or not. So in this case, it doesn't really change compared to the plus. But let's say you're looking for an A followed by a C any number of times, including 0 followed by a G. And so in this case, you'll have both matches that include ACG or ACCCG, but you can also match AG simply because the C can be there more than once or just none at all. If I were to change this, for instance, to a plus, all instances of AG now disappear because you need at least 1 C between those 2 nucleotides. So does everyone understand the distinction here? So here, the plus refers 1 or more. The asterisk signifies 0 or more. So it can either be there or not, and it can be there also multiple times. And lastly, the question mark is it's either there or not, once or none. And so in this case, what we have is we have AGs that are being matched, and those are cases where C is absent. But you also have cases where the C is present, but only once. If there's a string of C's, it will not be matched. So the question mark is 1 or 0 or once. So one of the hints I gave for the this challenge question is the question mark quantifier is quite useful in a case of phone numbers because something might or might not be there in the formatting. There's more than one way of doing it, but this is one approach that you can use is using a question mark quantifier. Depending on the different format, as you can see, in some cases something's there, in other cases it isn't. So, so try this challenge question, and we'll walk around and put up a red sticky if you have any questions, and a blue sticky if you've figured it out. Yes.
So I guess what I'm looking for is the blocks. Yeah. So trying to match up 3, 3, and 4.
Just to make sure that your regular expression is.
So like he wants to color it in the blocks of the 3, a 1 and a 3 because there's a 1 by itself.
Let's say I just throw in another number in there. You don't want to match that, for instance. You only want to match things that look like phone numbers specifically, and you don't have, let's say, any false positives. So if you're just throwing just a random number in there, you want to make sure you match all the phone numbers, but not that other character. And if your pattern is well built, you'll notice that you can match specifically phone numbers.
Where the problems go, like, are you preparing for?
Okay, so
Is this have?
Or
I see. Okay, yeah, maybe I'm not defining the problem well. So, what I'd like basically is for you to create a regular expression that matches the 3 numbers followed by another 3 numbers followed by another 4 numbers.
So not the character in between them.
Well, you need to take that into account somehow.
Yeah.
So you have to include that into your regular expression. And the thing is that character here, varies from one to the next. So in some cases it's a dash, in other cases you have parentheses, and in other cases you have a space, in other cases you don't even have anything. So this is a typical issue that if you were to deal with our regular expression, it would be quite annoying and very manual. But once you get familiar with regular expressions, trying to match only full numbers would become possible and would make your task a lot easier.
So specifically grouped 3, 3, 4, but with arbitrary country coding to start.
It could be anything. Yeah. You can, I mean, in this case, you can perhaps ignore the country code and just match rule directly for what is what looks like a phone number. And regular expressions can do that for you without you having to worry what's around it. So maybe we can solve this together. So what's one of the first things we want to match? And usually I do this in a relatively iterative process. The first regular expression I'm going to write is not going to work. It's either going to not match everything or it's going to be too permissive. So in this case, what we want is to match any series of numbers. In this case, I guess what we have here is any number. So using our square bracket notation that we've already seen. Now I want to match this 3 times, right? So, and then I want to match the same thing another 3 times, and then the same thing but 4 times. So obviously now I only have 1 match. I'm way too restrictive because the formatting of full numbers is too broad. Now something I'm going to introduce here just to make it not as ugly, and I'm jumping ahead a bit, but in regular expressions there are shortcuts for common patterns. And in this case, basically what I'm trying to match here are digits. And there's a shortcut to do this, which is just \d. So \d is just a shortcut which replaces the square bracket notation. So I'm just going to replace my square bracket notations with the \d, and you can go ahead and do the same. And this is just to kind of simplify the regular expression. Now, one thing I need to take into account, I'm going to go look at the first phone number here, and what we have is a dash that's between. But if I want to keep the match I'm already making, the dash is optional. So I'm just going to add the dash followed by a question mark, because the question mark is 0 or 1, right? And so now I'm matching 3 out of my 6 phone numbers. But if you look at the 4th one, you'll notice that it has spaces instead of dashes. So what I can do is, now here I have an option. It's either a space or a dash. And so what I can do is instead of having a dash specifically, I'm going to put it in square brackets and add a space. And you can just add a space by just typing space. So here what we have is 3 digits followed by a dash, a space, or nothing, followed by another 3 digits, followed by a dash, a space, or nothing, followed by 4 digits. So now we have most of our numbers, but there's still the one with the parentheses that is there. And we should only expect parentheses for the first 3 numbers. I think that's pretty reasonable to assume. And so what we can do is we have an initial parentheses,
that is either there or not. Now this is, here we have a problem, and I guess I should have introduced this previously. So parentheses, I've already mentioned, are they're a way of capturing or grouping a pattern. And so in this case, now it's trying to be interpreted as that, but I just want it to be a plain old parentheses. And so to do this, we use the backslash character. So this is very common in programming. It's called the escape character. And you're basically telling regular expressions, just don't treat this parentheses as anything special. It's just a plain old parentheses. And here, what I want, and here I have the question mark because it's either there or not. And then after, I'm going to do the same thing. But with the closing parentheses, which I also need to escape because otherwise regular expression is going to think it's looking for a group while it's not there, followed by a question mark. And now I'm matching all of my phone numbers properly without any real false positives. So obviously, if you look at this now that we're done, it looks really ugly. And that's regular expressions. It looks really ugly, and it's pretty dense when you try and look at it. But the way you do it is you try and build it iteratively, and you try and understand what each group does. And slowly but surely, you'll have a regular expression that matches everything that you want. So if I had a much bigger block of text, I can then use this regular expression and extract all phone numbers that came up in that block of text. Which can be pretty useful.
You could also replace, say, for example, the parentheses and the dash and the space with just a single character and a question mark, right?
Pardon?
You could replace, like, to make it a little bit more readable.
Yes.
You could replace that bracket that's containing the space and the dash, just like a single character matching, like a period.
Yes. So
followed by a question mark.
That's a good point, and we're
more flexible.
So thank you for the segue. So the next part is just look at character classes. And so I've already introduced one here, and it's the \D. So character classes are a way of referring to a group of characters without having to list every single one out. So the \D is a character class that refers to all digits. And another one that Tiffany is alluding to is the period. So right, that's what you were referring to. So the period basically matches anything. So anything except a new line, typically, the period will match.
That would also be dangerous.
Exactly.
Yeah.
Exactly. So this is, and obviously this is a trade-off. So here the period is can be used, but if I don't know exactly what, I mean, if I had, what if I had this number here?
Some people do, I guess, for this case, some people do use dots in between the phone.
Yeah, exactly. So I guess you have to be careful.
Yeah.
So again, so this is so there's different ways of solving this problem. There's usually many different ways, and a lot of it also comes down to how stringent do you want to be in your regular expression. So here, we're going to move on to the rest of the character classes. And for this part 3, I'm going to ask you to copy paste this list of emails into the text box. I'm just going to remove this just so that everything fits. But what I'm going to want to do here is match the first part of each email. So anything that comes before the @ symbol. And so I guess one thing you could do is list the alphabet out in the square brackets, but surprisingly, there's a shortcut for this. And what you can do in the square brackets is specify a range. So in this case, what you can do is specify anything from A to Z. And so this matches anything in the alphabet, but you have to keep in mind that the regular expression is typically case sensitive. Now here at the top, you have an option to not have that not be the case, but typically what you'll do is you want to maintain that so that you don't have any unexpected matches. Now, what I'd like you to do is just, if you can all enable this option at the top in the middle, where the caret and $sign match at line breaks. This is typically the default. In this case, you just have to enable it. So can you just please make sure to enable that? And the reason is what we want to do is we want to anchor our regular expression at the beginning of the line, because here all of our emails are on their separate lines. And so what we want to do is we want to anchor at the beginning of the line, so that we are because we only want to match the first part of each email. And in this case, we have just a few of the emails, and you see a big batch of the emails in the valid emails don't get matched, and this is because they start with a capital B. And so to solve this, what we can do is we can just add in the range for capital letters, where you just have capital A dash capital Z. And so
you need to check that box and enter that.
So yeah, here you need to add the caret, which is the little hat symbol character, and this basically refers to the beginning of the line.
Then why do you need to check that box over there?
Because if I don't, it doesn't do what it's supposed to do. I think it just looks for an actual caret. So if I were to do this, actually I'm not sure what it does. All I know is that I think typically in regular expression, this box is enabled.
I imagine you either need to put that sign, the hat sign, or check the box. If you do both, it works, but one of the two also works.
Okay, yeah, that's probably it. I guess I'm being explicit with the caret, which is what I'm used to. And typically what probably you'll run into in many of the tools that I've used. So in this case, we're just being explicit that we want to match and we want to specify the caret, which is the beginning of the line. So in this case, okay, I match all the first characters, which is fine. If I want to match everything, what do I need to add? A what? So if I add the dot, it would match the second character. So what I'm looking for is I want to match these characters multiple times, not just once. Yes. So adding a plus basically takes that little group, which is any letter, basically, lower or uppercase, and expands it as far as it can go. Now here we have an issue where the underscore isn't part of the alphabet. So if we want to take that into account, what we can do is we add the underscore. We add the underscore to our square brackets, and what we've expanded once again our emails. Now, next issue in line here. If you look at the one of the emails here, 1991 isn't being matched, and that's because again digits aren't part of our regular expression. So here we can add the digits and using the same range feature that we've been using, and now we have that included. Now this pattern here, where we have any letter, lower uppercase, the underscore, and the number, this is a very common pattern. It's basically any character that can consist of a word. And so what we can do, there is a character class for this, similar to our \d. In this case is \w, which stands for word. So here's just a shortcut of referring to all word characters. But we're still not there yet. We have a few. We still have a few emails that are getting excluded when they should be included. So in this case, what we're looking next is the period. Now, if I add the period here, obviously this is not what we want. So what's the problem with this regular expression? Pardon?
It doesn't really does it though.
So yeah, so what does the dot mean in this context? Exactly. So it's matching anything. And in fact, what does the plus now apply to? The plus is only being applied now to the period, which is anything. So this regular expression is basically not what you want at all, because it's basically matching anything that is, basically what it's doing is it's matching anything that starts with a word character followed by any string of characters, which is not what we want at all. So what we want is we want to match a word character or the period. And so for this, we need to bring back our square brackets. And so this brings up an interesting thing. And actually, when I was creating this workshop, I also was surprised. So here, the period is supposed to mean any character, right? So why isn't the dash being selected for? Actually, why isn't the @ sign not being selected for? And the thing you have to keep in mind here, and this might change from language to language, but in this case, the fact that you put a period in square brackets, it's kind of implied that you just want the regular period. Because if I want the character class match anything but the new line, I wouldn't be putting it in a square brackets because I would just do this, right? So in this case, the way this is implemented, the period just means a regular period. I mean, I guess, I don't know if I can backslash and it doesn't break anything. I mean, if you want to be absolutely safe. But just something you have to keep in mind of when you're using a character that's considered special, like the plus. In other contexts, you have to make sure that in that context, if it means the same thing. So in this case, we are lacking. We need to add the dash to be able to match those few that have the dash before the year. And then we've matched the beginning of our emails.
Excuse me, but Bruno.
Yeah.
So
Sorry. He put up his hand first. Yeah.
Sorry. Just wanted to check, if you do backslash period in there, will it match literal backslash?
So that's a good question. So I was wondering that. So let's see. Let's say I would consider this, I guess, an invalid email. I'm going to just add one here, and I'm going to just add backslash. What happens if I add backslash? So it doesn't. So what if you want to match a backslash? What would you do? Yeah, you escape the escape character. So that's very typical in programming languages. Is in this case what we have is so I guess it's like a fail-safe. Is that okay? It's implied if you add a period, you only want a period. You don't want to match anything because otherwise there's no point in putting in square brackets. But in case you forgot that, which is what I actually did when I was writing this lesson, I automatically put the backslash, but then realized I didn't put the backslash, expecting to put a warning in the lesson notes, and then I realized I actually did what I was aiming for. So in this case, I guess it's just a safeguard that both mean the same thing, just given the context. And another, and this also introduces the idea that if you want to use a backslash, you need to escape the escape character. So here, what we have, and we can just add the @ sign here. What we have is sorry, yes.
Yeah, we have a couple other, I don't know if you want to take over first.
Yeah, Sepide.
So why we have the digit highlighted here? Because we have the word and then dot.
Yeah, so the word is any letter, underscore, or digit.
Okay.
So it includes the digit.
I see.
And yeah, sometimes I get confused. Is there another one? And I would just Google it and find out. And I also included it in the lesson notes. They're equivalents, and so you can. But yeah, these character classes you can figure out online, looking up online what they actually mean.
And they might also depend on the application too, whether they're available or not.
Yeah, exactly. So this is an unfortunate thing where like there are slight implementation variations depending on where you look, the language, how old the software is. So this is just an annoying thing altogether in programming. Here we're all using the same website, so it's the same. But that's something you have to be aware of. Is a regular expression in one context might not be directly translatable into a regular expression in another context. Yes.
Question or comment. The dash is funny there because you can, I guess because you use it in the range, like 0 to 9 or A to Z, you can only, it has to go at the end of the square brackets to be actually used as a character.
So good point. So yes, Tiffany is right. So here, just to repeat, we have the dash here. But yeah, if you remember, we were using dashes like this right before to indicate a range. And so obviously that's not what I want here. And so if I put it at the end, it's implied that there's no range, and I just want to match the regular dash or the hyphen. So
Okay, so you can move it earlier up in your pattern if you use the escape character.
so if you're using a character and it's doing something funny, like it's a special role, the way you get it to act normally is an escape character. So that's your that's usually if there's an issue with regular expressions, escaping some characters is often a solution. Don't just start escaping everything, so that'll just be terrible. So I think at this point, I have the next challenge question, which is basically I want you to match all of the emails in the first section, but none of the emails in the second section. So I want you to write a regular expression that ensures that only matches valid emails. And that includes the first and the second part. So you can start with what we have here, add the @ and then match a valid URL. And here, and for the challenge question, we have challenge question. I have a hint here, basically describing what you can expect in terms of the URL. So the URL, the only thing that can come in a URL are letters, numbers, and dashes, but the dash cannot be the first character in your URL. So try and build a regular expression. This will be tricky, but try and build a regular expression that allows you to only match the valid emails. Put all of your blue stickies down, and if you do figure it out, put it up. Otherwise, if you have a question, put up your red sticky.
So we'll remove it. That's usually what I do. So you start seeing it starts matching things that you don't expect. So it just tells you to explicitly say, I just want from the beginning of the line going this way. And you can do this in this case because you know the emails are at the beginning of the line. If that wasn't the case, let's say this was in a big block of text, you have emails and text, you'd run into issues because, for instance, this guy's email, you could whatever comes after the apostrophe is actually a valid email, right? So you would match that obviously. So the exactly. Exactly. So then why does that because here it cannot reach the @ with that. Because if you remove the @ then it will go on. But if you have the @ it can't reach the @ because the apostrophe isn't an option in this case. Word. You got it then? It's tricky because URLs, they can have either one top level domain, which is the .com, but it can have more than one. So let's say if you open, I don't know, a satellite campus in London, you have sap.co.uk, you have to be able to match that too. And you have dashes, but they cannot be the first character in the URL.
So which emails do people are having trouble matching?
I'm having trouble eliminating the SFUCA.
Yeah, I guess that.
This one?
Or no, not the one with no period.
Oh, that one, yeah. So yeah, you have to guarantee that there's a period, but it can be more than one. Hint, hint. There can be one or more of those top level domains with .com.ca.
Just a side question.
Yes.
You've been trying to match everything.
Yes.
So is there a script, a program, or something where you give your candidates and it comes up with the expression that matches everything?
Good question. I don't know of anything that you can give it basically a list of positives and a list of negatives and have it generate something. You got it. It feels so great when you got it. I don't know of anything myself. I don't know if it's possible. Maybe it is. That's a good question. I'm assuming maybe not even regular expression based. You can probably just use general machine learning based methods and train it. But I don't know if there's a method that generates the regular expression for you.
trying to recognize.
Sure.
So you have to figure out like what's the
Mhm.
what's the simplest regular expression.
But then there might be cases that you don't predict what happens to be in your.
Yeah, so that's a huge issue, right? Is false positives or false negatives. So here I'm making it really easy for you, and I'm just putting this is the ones you want to match. These are ones that you don't want to match. But this invalid emails is nowhere near being exhaustive. So there's probably tons and tons of other ways people can screw up writing their emails that are not listed here. And you want to make sure you write your regular expression so that it excludes those. And testing, trying it out, going over your results and seeing that you don't have any false positives. So blue stickies up if you got it. Red stickies if you are still having trouble with a given email. Which email are you having?
Just I didn't have in this one,
Actually,
the third one.
potential question. It's related to the question of given list of names, with the smallest finite that
Okay, I see what's happening.
Yeah,
So
I
that's
meant-
what I think your mind is curious.
Or I
What is
think
it?
just go through all the
Anything
options.
any character.
Exactly.
One.
It includes a paragraph that can match anything. And in this case, it could be anything.
Yes.
So what you want is you want to match just a paragraph. Or how do you do that?
Put the paragraph in the bracket or no difference than that.
No, so what you want to do is run escape dictionary because otherwise it needs.
I tried that.
So the first letter is.
So we're getting there, but right now you're matching only the first character after the period. So what do you want to? You want to match something again?
yeah, I guess.
Has everyone get it? You got it? Good. Oh, you also got it? No worries. So here you're matching the first character after the act. So if you want to expand that a bit, how you can use it. Which quantifier do you want to use in this case? Because you can match any word character, but which quantifier, how many times do you want a letter to appear after the S? Which is how many number of times? Because this is the tricky part, is that it can be any length, right? So. So the curly braces is when you specify a number. So, like this. So how would you describe how many characters that it comes after the act? It's a variable number, right? So do you remember what we did when we were looking at how to match we were looking at how to match all T at any of those values, or all a bunch of T's, 2 or more T's, how do you the notation for it? Yeah. Any curly braces. I would say about it, but this is a topic. That's it. So you got it. Put the comma. I don't remove that. So this works, right? You're going up to the period, but there's a shortcut for this. You can just replace all of that curly brace one comma curly brace with just a plus. Because the plus basically means one or more. Yep. Okay, so I'll let you. I think we need to wrap up a bit. So there's multiple ways of doing this. I'm going to just solve it my way, which is not necessarily the right way, but there's a way, and then we can wrap this up. So here, what I said is I need to match a letter, alphanumerical. We'll throw in the capitals. Doesn't really matter when you actually turn to the URL. But no dash as the first character. And then I want to match that exact same thing, but I'll include a dash. And I do this any number of times. Now what I want is dot something, and that a variable number of times. It has to be at least once. So what I'm gonna do is I'm gonna put this in parentheses, and I'm gonna put dot. But I have to be careful now, because I want to escape this, because I want to act as a regular dot. So these are round parentheses, which are not the same as square brackets. Here, the round parentheses just allow you to group things. It doesn't change the meaning of what's actually inside. So we have here, and then I'll use the same. In this case, the top level domain can't have a dash as far as I can tell. So what we'll do is we'll have any number of letters, and for this, any number of times. So basically, what comes after the at, because we did that before, so I want any letter, upper or lowercase, followed by any letter or dash, upper or lowercase, any number of times, followed by a period and a series of letters, and that can be once, twice, 3 times, 4 times, doesn't matter. And so this is what I came up with.
You can add numbers to every domain as well.
So I think this, so yeah, you're right. So here, this can be this, and this can be this. So what comes, the first section, well, okay, there's other possibilities, but this is basically
I think you want,
one solution.
I think you want a dot in that first one and not in the last one, because the .ca or whatever
Yes.
does not have any hyphens in it, but you could have like at www.engage-sfu.ca.
So yeah, so that's what I just thought. Is there at www
You can have arbitrary subdomains. It's just
in email?
I think so. I've at least at my old university, everyone had like math.uvic.ca.
I think this brings up a good point.
Oh yeah, mail.mcgill.ca. Yeah, okay, you're right.
Your regular expression is only as good as your negative test case.
Yes,
And
exactly.
It's good to have these invalid emails. Like it's anytime you're making a regular expression, it's super important to have negative things that shouldn't work and
Yeah.
things that should work.
So just to repeat this, basically one thing, and I'll add right now a case is another invalid email would be let's say mail dot. All right, this is a valid email, but here I can have a dash here, and let's say I have engage dash here. So
That should still be valid, right?
yeah, sorry, this is valid, yeah. So this is problematic given my current regular expression. And so one way you can solve this is this pattern that comes. So I guess you can divide the regular, the part afterwards. So after the add, you can divide in 2 sections. There's the .ca, .com, .co.uk. So those are what we refer to as top level domains. And those are very restricted to just letters. And then you have the rest and maybe numbers. And then you have the rest, which can have dashes. And so what you can do is you can wrap this big section here in a parentheses and add a plus. Here you can have, this is starting to mess me up. So wait a sec. Try and get that last one. And I'm a completionist. I'm gonna have to do it. So yeah, like you suggested, you move the period into the first part, which can be repeated any number of times, and then you have, I guess the only issue is if you have a top level domain that has 3 sections. Oh no, that still works. No, I know why. So okay, no, it works. Yeah, so that's just me going a bit far. Yeah, exactly.
Please for your answer
Yes.
Bruno, and maybe anyone else who figured out a different way to solve that problem.
So here, if you go on Etherpad, and thank you very much for, this was challenge 3, right? So this is, I'm just pasting mine here. And thank you for everyone that has put their information here. If you haven't, I would invite you to create a GitHub account and either put it here after the fact or maybe at the next workshop, come and show up and paste it there. And we're going to try and keep the website up to date so that you can come and attend it. So yeah, I think that's going to wrap up. We're 10 minutes over time, so we should probably wrap up. That's going to wrap up our introduction to regular expressions. And okay, so important, you have your stickies, blue sticky, red sticky. Write one thing that you enjoyed about this workshop and one thing on the blue sticky and one thing you would like to see improve on the red sticky. This is my first workshop, so I'd appreciate any constructive feedback whatsoever. I welcome it, and I'd love to become better going forward. So please don't be shy on giving pieces of feedback on the red sticky, but if you have anything good about it, please include it on the blue sticky. And just post it on the wall on the way out, and we're going to take a picture of it. So just put a mosaic of blue and red stickies. We can take a picture and we can share it among us ourselves. So thank you, everyone.